Welcome to the Crazy Wisdom Podcast. My guest today is Sterling Cooley. He works on the topic of the vagus nerve, ultrasound, and human consciousness. And he just published a new theory called Niemertin vagus nerve origin theory. And you can find him at ultraschool.com, ultraskool.com, to learn more about all the things we're going to talk about. Probably going to get into some weird avenues of investigation. So welcome to the show.
Thanks for having me, James. Yeah. Or no, sorry, Stuart.
That's right.
Stuart also.
Yeah.
Okay.
So the vagus nerve, I've done a lot of thinking on the vagus nerve. I went through a yoga therapy training class, and they would always talk about the vagus nerve. Seems like there's a lot of interesting stuff going on there, but of things that are created out of the imaginations of yoga teachers who are kind of taking things and putting mythical things. And there's also this sort of like there's science, and then there's the lack of God and the Nietzschean like God is dead. And so people are then trying to take science and put science into things and create magical worlds where science is doing all these things, which it's not actually doing. And then we're going to talk about ultrasound. We're going to talk about human consciousness. You post a lot on Xenon, and I don't really know what Xenon is. That's part of the reason why I want to talk to you. But I imagine it's messing with consciousness, and therefore, in the messing with consciousness, you're allowed to figure out what is going on with consciousness. At least part of it is. Feel free to respond to anything I just said there. What's your take on all that?
Yeah, that's correct. Xenon apparently, according to OR, which is orchestrated objective reduction, Stuart Hameroff, Roger Penrose model of consciousness. Xenon is so small; it's able to affect at the angstrom, like 5 angstrom level between different tubulin across the microtubule, and it gets in there so close that it affects van der Waals oscillations. And so xenon is a noble gas, but it also has anesthetic properties. And technically, it's not picture perfectly clear why it should work in the first place at all. Shouldn't necessarily, because it's not contributing electrons. It's not the
Okay.
only way xenon could work is through a quantum mechanical
Ooh.
force. That's the only way that it could work. So it is doing something of that nature. But for those who have done it from a surgical perspective, because it is used in like high-end hospitals, it's a very expensive gas. It's $200 to $300 per treatment, just in
Wow.
terms of the cost of the gas, which isn't insane, but that's the I believe that's the baseline cost for the hospital before they charge you as the patient, so it can get more expensive than that. But um, there's an anesthetic effect, and it's very potent as well. If you've seen the Vice documentary with Hamilton Morris, he goes to a xenon clinic in the Czech Republic, and he found that it was extremely euphoric. And
Ah.
he described it as like one of the most intense euphoric highs he's ever experienced in his life. And it was like from his head down to his fingertips, down to his toes, like every part of his entire body was just like vibrating with just pure joy, essentially. Um, One of the things he doesn't mention in that documentary is the sometimes pretty extreme psychedelic effects that can happen from xenon, which are like are possible but not often talked about. So probably kind of putting these concepts together is that if you do want to understand consciousness and you go by kind of an OR interpretation, which is microtubules hold consciousness in a sense. That's one place where you would find consciousness in the human body for sure. Is that, yeah, you'd want to perturb it,
Yeah.
push on it a little bit, go like, hey, what if I jiggled this here and then this, and then what happens in my consciousness? And Xenon does offer that as as a tool.
Yeah.
And so now humans are doing it to research it. But what I find even more interesting is a quantum lab, the Google Quantum Lab is now growing brain organoids on silicon wafers for quantum computing applications. So living tissue. And guess what gas they're giving it?
Xenon.
Xenon. They're giving brain organoids xenon gas at Google to study the effects.
Oh,
Most
interesting.
likely, they're trying to get into that microtubule as well. So these ideas, it's funny because like I know OR just in general, it's been very popular to like poo-poo it in a sense, like, oh, this is just like stupid, dumb thing. And it's like, yeah, but like the major labs are just like obsessed with, they're going in this direction. Um, and so yeah, like anyway,
Brilliant.
but yeah, so Xenon's very interesting, but
So I've got a bunch of follow-up questions there.
yeah.
So let's go into what a microtubule is. So I've researched them before, and I've got them up on Google and the images. But let's start at the real basics. We've got a cell and we've got brain tissue. The microtubules seem related to the nervous system. And so the microtubules are in nerve cells, or are they in other cells as well?
Microtubules are in all of your cells, all of them. And they mostly exist on the boundary layer outside of the cell. So when a cell is in a circular form, just floating around like a sphere, and it starts to grow arms out, that's entirely a method of a microtubule actin
Mm,
matrix
mm.
forcing itself outward from the cell. So when you see those neurons growing,
Yeah, that's a
that's
microtubule.
microtubules. Think, again, this is the where the real debate is I say the way I see it is that these microtubules are thinking, let's
Oh,
grow. They have agency to grow outward in this direction. But if you go to a commoner
yeah.
neuroscience lab, and I mean like Harvard and Stanford is a commoner neuroscience lab that are very stuck in this older school uh, perspective. It's unfortunate. There's lots of implications of why
But
it's
it's the way
bad that they're
science
stuck on that.
it's the way science works, right? Is that each new
It's
paradigm needs
slow.
the other paradigm, and part of that makes sense. It's like a opponent processing, which is another term I think from neuroscience, which is that we've got the sympathetic and the
Yeah.
parasympathetic nervous system, and they're both opponents to each other. So it's like this fact that there are a bunch of old scientists who own the paradigm and they'll need to die out is like a good thing, because it's like this tension between tradition and novelty, which is important. But at the same time, it
Yeah.
really is annoying to any of us who want to understand the future, because we've got a whole bunch of
Yeah.
people who are saying, no, that's not the way it works, and are very like stubborn about it and annoying, because it feels like they're not
Yes.
open-minded. But eventually we will end up in that same situation once we're above 50 or 60 years old. And it's funny because we're talking about neurons and microtubules, and that's all because of that. Although I do
Yeah.
think it's possible to keep an open mind later on in life, but it's very
Yeah.
rare, I'd say. So, okay, so let's go back to the microtubule. It's kind of branching out. It's in all sorts of cells. Why do they think that it's so important? Why do you think? Why do other people that agree with you think that it's so important for consciousness? And what are these older scientists pushing back on?
Yeah. So that last part of your question, I think, is the key reason why you don't hear about microtubules. Technically, I would just say that it can denote the difference between, are humans determined
Hmm.
or do we have free will? It really boils down to that type of it's that serious of a competition, essentially. Are humans like clay goblins or clay golems that you can control and mold to your will.
Ooh.
It's funny. Or are we free human agents capable of doing great things? And I definitely take the stance that we are that. We
Well,
are
and we
amazing.
and this is, I mean, crazy wisdom is about tangents, and I want to kind of give another
Mm,
tangent, which is
mm,
is it a duality between free will and determinism, or are some things deterministic and some things free will? Because it also brings in AI into the
mm.
picture, which is so interesting because the last 50 years of automation have been about deterministic automations. And now we have this probabilistic thing. And that
Right.
determinism versus probabilistic also exists at quantum mechanics. So there's a determinism that determines where the electron will be. It's in within a and the quantum part is about the probabilities of where the electron will be. Part of that, I've talked to scientists
Mm,
before, part of that is deterministic. Part of it is probabilistic, even at that where the electron will be once it's observed. And so
right.
and now the microtubules, and this is probably a good time to go back to the quantum part of what you're saying. The microtubule is quantum. Can you go more into what the relationship is between microtubules and quantum mechanics?
Yeah. Okay, so how did it start in the first place? I believe it was so Stuart Hameroff in the 1970s was observing um, cell division. And he was like, well, how does the DNA know how to split itself into two and then go into two separate sides of a cell? There seems to be these fingers that grow out from both sides and reach in and grab the chromosome and pull them apart, and then suture the cell back into two holes and then pull them apart. How does it know that? Like a simple but basic kind of question. Not ask, he's a very smart guy, not asking in a dumb way, but it's like, no, but really, like, how does it actually know to do that? And I kind of narrate this as the head of the lab was like, come on, Stuart, we're not, that doesn't matter. It's like, yeah, it probably actually does if we could figure this out. I mean, it's happening all the time. And so Stewart looked at this for like a decade, published a book called Ultimate Computing in 1987. And this is like a textbook on this, where Stewart was laying out the plans, the grand plan for the ultimate computer,
Wow.
which would be a microtubule based like quantum computational system, essentially. And then Roger Penrose published The Emperor's New Mind, or yeah, The Emperor's New Mind book in 1989, so 2 years later. And then it's funny because they really did kind of, they were pointing at about the same thing. Hameroff was saying that these microtubules at the scale they have are able to do like a kind of a very singular oscillatory mechanism. And I don't think he was necessarily talking too much about in a quantum way so much. Not to the specificity that Penrose would know, because he's can do physics like that, but in
Mm.
quantum physics. But in Penrose's book, he said that, okay, so this is kind of interesting. Are you familiar with the concept of like renormalization in quantum
No,
physics?
no, no, please explain. Yeah.
So renormalization is a process by which if you're doing so if you think of like this, an arrow pointing up, down, left, right, north, south, east, west, there's a process where on the level of time
Hmm.
that the arrow kind of starts to point on the mathematical equations to infinity. But renormalization is the process of, as soon as it gets close to that infinity line in quantum physics, they just cut it off. So there's a field of quantum physics, like this is Feynman, Dirac, Hawking. Like these are big names in physics addressing this particular facet. There's no, it's just a made up rule.
Yeah.
They're like, we can't really deal with the infinity part of this. So it's called renormalization, and it's absolutely fascinating.
Yeah.
It's why quantum mechanics people, when they try to do Planck level math,
Yeah.
they have always different decimal places there. There's no correlate, like
Because
they're
there's this infinity that's messing everything up because we can't model it.
right. It's impossible for a computer to model that, to model infinity.
So they have to move
So
a placeholder for infinity in computer models, basically.
yeah, it's not, yeah, it's like, yeah, that's kind of what they're trying to do. But
Okay.
even then, still, it causes some issues. It doesn't, again, you can say everything's like
Yeah.
you could say like, okay, we've modeled 99% of everything. The 1% that flies off into infinity literally would technically fly off into infinity. That doesn't matter. So they're saying the 1% thing that they can't account for there's no way that could contribute to your agency or free will or your access to the quantum world. Okay, so Penrose specifically kind of addressed this in The Emperor's New Mind, but he also addressed this from an AI perspective, in that AI people thought that they could, again, compute with a Turing machine, like a Turing complete machine, just like make a whole human brain and have artificial general intelligence or super intelligence. And he's like, but a computer can't do those infinity components. The human brain could be doing something like that. But the funny thing was, Penrose didn't know about microtubules, and he hadn't studied microtubules much at all. He's not a biologist. And so, but he said specifically that according to the equations, you would find this ability for cells to hold and support and measure infinity
Interesting.
at the 3.7 angstrom level. I mean, we're talking very tiny, same area where xenon affects too, okay, through quantum mechanics.
Yeah.
But he just said, Penrose was just like, yeah, it would be 3.7 angstrom, 2 to 4 angstrom region. And then somebody sent Stuart Hammer the book, and they met up and they talked. And it turns out that the space between the specific phenyl rings, the aromatic rings, like this one, kind of they look like that, in microtubules is 3.7 angstroms exactly, right? In London dipole forces. And it's not just in a few places, they're all strung together perfectly. They were selected by an agentic self-building force to optimize for the force of contacting the infinite.
Yeah.
Whatever that refers to, whatever that takes you to.
Yeah.
That the microtubules have those exact features that Penrose predicted would be necessary for a human brain to support what renormalization is trying to cut off and then claim that, oh, we figured it all out. That's where he says that that's where he puts consciousness too. So once you start, then that's the term that should be used to describe consciousness. And that when you and I are having a conscious experience that feels again, it's like feeling an emotion, feeling a feeling. There's I don't know, it's hard to say. It's like love, for instance. We all have some sense of love. I'm not saying from an objective position, because it's entirely subjective, the feeling of love. But if you look at the works built out of the feeling of love, it's I feel infinite vast. It'll never, it's this all these terms that humans use to describe the feeling. And it's like, maybe different feelings have these interesting long tails that a computer, that's probably why a computer can't feel. But if a computer could have the long tail, might be able to integrate that somehow. And you'd need a microtubule, most likely. I mean, yeah, you basically, the first computer that can feel will have microtubules, and we'll be giving it Xenon.
Yeah, and that Google Brain part, I'm definitely going to go do a bunch more research on the Google Quantum Lab using Xenon on the organelles. And for those listeners who aren't extremely online, some other lab, I believe in Europe, was talking about how they were creating organelles, like little tiny brains, in order to do computation. And there's a lot of controversy around that. And so, okay, so there's a lot of things we can discuss here. There are a couple questions I had that were very tangential that were also really interesting, but now they've gone away. There's consciousness, infinity. We are part of infinity because we exist as a part of infinity, but then we've got this brain that needed to learn how to survive from a very ancestral point, and so it splits things into parts. And that splitting of things into parts allows us to navigate the phenomenal world in which we all exist. And this goes into Ian McGilchrist's books, and how he talks about the right versus the left brain distinction, not in a pop psychology way, but a very like rigorous way, and talking about how one part of the brain splits things into little tiny pieces, and the other part of the brain creates the whole. But it still seems like an image of the whole because the brain itself can't really comprehend infinity. And then there are parts of it, like you're talking about, that allow us to like a placeholder of infinity and experience infinity in the subjective love way. But we're still these beings that are separate or feel separate at very, very like deep levels. What part of that do you agree with? What part of it do you disagree with? What is your take on this area of parts versus whole?
Yeah, I think the area I'd like to zoom in on is this counter to the microtubules, which is the synapse in the neuron, is typically looked at the unit of computation in the human brain.
Yep.
And it's such a lie. It's such a lie. It breaks down the further you look at it. It's insane that it's still promoted. Okay, look, I have a core belief, and I've found it to be true. Follow the money. Okay. Why would it be? And this is almost where you get to the issue of does the old metric work of like, okay, the old guys, they're the old guard, but eventually they'll pass on. And I'm like, yeah, but it's never been so like industrially, commercially embedded to push this model. So I hope there's a meta understanding of what I'm saying, and I'm not going to get too far into it. I don't want to get myself in too much trouble, but yeah, it's bad. But the synapse, okay, so the synapse model is like, you have a neuron A communicating with neuron B, and it's like this juicy bouncing of molecules between the two, and that's like your model of computation. But it's so okay, and then you have like membrane polarization, you have like electrical pulses going up and down. But I've never once seen a neuroscience textbook account for the fact that there's a molecular enzyme called CAMK2, calcium calmodulin 2, or II. And it can, so it goes right before the synapse, locks onto a microtubule in a hexagonal pattern, inputs phosphorus, phosphorus can maintain spin in quantum mechanics. So it imprints itself 6 times with phosphorus, which maintains a quantum spin, which can be entangled with another one. How do I do this? Like that. And then it jumps off, goes through the synapse to the other side, and imprints itself again on the other microtubule across the gap.
Yeah.
Now, I think of these CAM-K2s as jumping telephone, like those old school patchers in the old telephone labs. You know, it's like, I'd like to call Chicago, right? So it's quantum mechanical entanglement with phosphorus in spin between microtubules. Well, I had learned about the CAM-K2, it's called the hollow enzyme, or kind of looks like a poodle almost, and how it bulges out on 6 different sides with these big, kind of like fluffy components that bridge right onto the microtubules. And I was like, okay, so I had the opportunity to meet with a quantum computer engineer in San Francisco. Did like, I think it was like the Embassy Network or something like that. There's like an event we had. I was like, hey, can I talk to you for a second? And I was like, can you tell me about what you think of this model of like quantum computation on the surface of microtubules with phosphorus? And he like, his like eyes lit up. He's like, oh, well, we use phosphorus and we have voids in crystal, in kind of diamond, where we measure what we do is we measure the voids to try to semi-measure the phosphorus without pulling it out of spin.
Wow.
And so the microtubule lattice is probably what is measuring at a distance the phosphorus to be able to continue the circuit. It's like a lengthening process almost. It's like the microtubule wants to be just a continuous long thing. And you do find in nature that there's an optimization for just make more microtubules, make them longer, make them more compact, denser, protect them with myelin. So there's this optimization function for like just more. It's just like more microtubules. Let's get more.
Wait, what are microtubules?
And
You said they're in. You said microtubules are in every cell. Are they in every cell in every species?
no, there's a precursor. It's called I call it FTZ. FTZ. It's like FSTZ, FTZ. And this is an elementary tubulin that came before. This is real. This could get into something really fascinating, by the way. So we'll go there.
Yeah.
But before the microtubule, there already was a tubulin type of thing. The microtubule that we have today is I would say, an evolutionary jump to the next more complex form of that same rudimentary form of tubulin.
Yeah.
And that does cellular division too.
Yeah.
That does exactly the same thing that a eukaryotic cell does. And it's got a length of the cell body. The microtubules form from the centrioles. Or I need to look into the FTZ more, because I don't think they have centrioles in a microtubule context, but they are clearly cross-communicating with each other, wrapping around the center of the cell and then squeezing it shut. They're doing that whole thing. And they don't have DNA, so the cell can replicate itself without DNA. So my conception of DNA now is that probably microtubules created DNA through an agentic process. How I can say that is we're blessed now that we're in Orcoar world less concerned about sort of the dialectics of the theory.
Yep.
There's this great guy named Dante Loretta at the cosmology lab in Tucson, Arizona. And he did a project called Osiris X. And this was to send an actual satellite, a probe, out into space. So now we're talking like rockets and cosmology stuff, right? Yeah. Not just like chalkboard calculations, okay? So he sent this probe to this asteroid called asteroid Bennu, Bennu. You should definitely look into this.
Yeah.
And he's given talks and stuff at the Science of Consciousness event. So you
Yeah.
can see the full, it's an amazing story. Launching it, putting this probe on this asteroid into a carbon-rich pocket.
Yeah.
They selected this one because it was very black. It had a lot of carbon on one side. And they shot a probe, like a proboscis almost, into the soil and sucked in as much of the carbon as they could into their container. And then launched it back to Earth, landed in the Utah desert, was transported by the federal government back there, like sealed, like they had to take all measures of containment. They're like, we can't let any samples from Earth get on or into this sample because people will start to doubt the veracity of the results or what we find. And upon doing pretty like the kind of work that a pharmaceutical company would do to analyze the molecules, found the FTSE tubulin essentially in that carbon dust.
Wait, and no life. No life.
No
Just,
life, but probably something like a proto-consciousness,
actually,
you know?
Yeah.
And the interesting thing was the thing that's interesting about FTSE is that it lacks tryptophan. You need water to make tryptophan. You need liquid water to create tryptophan,
So
and tryptophan's on planet Earth. Yes.
So asteroids slamming into Earth, having this precursor that allows to mix with water. There we've got how life comes on Earth, basically.
Yeah, exactly. And so that supports the idea of panspermia, which is that it's the theory of cosmology that says like carbon naturally wants to like form into a complex machinery, sort of nanomachines like FTSE. And even today we still have FTSE on the planet, still doing stuff though. It like FTSE doesn't need tryptophan to do anything. FTSE, when you throw it into water, organizes into a tubulin network and starts doing shit, starts doing stuff, forming, you know, lipid layer for a cell. It just seems to deeply, innately have a process that it does.
How do you deal with the scientific materialism that says that everything you just said is so far beyond the paradigm? How do you deal with it, like psychologically? Because there's this force, and this might get into the sort of like the danger zone of talking about these things when the thing itself, like this danger zone, it feels like it's been weakened gravely by COVID, but not within the industry itself, not within the thing. Can you talk more about this?
Well, I can I just want to touch on one brief thing about, so in COVID, Stuart Hameroff and Craddock, Craddock, Craddock and Tazinski, they usually do a lot of the molecular modeling of microtubules to sort of help to kind of help validate some of these ideas with Hameroff. They often co-author papers. They did one on the spike proteins of COVID. Now the spike proteins, you know, linger in the cell.
Yeah.
And the spike protein specifically is the thing doing a lot of the like purported damage. Now the place where the spike proteins want to latch onto are on the centrioles, which a centriole, by the way, is just microtubules stacked next to each other in a tight configuration. A centriole is considered, that's the thing that when when it's time to divide, the centriole develops a matrix membrane around it, grows microtubule arms and grabs the DNA and pulls it apart and then closes the cell. And the centriole then replicates itself. There's two parts of the centriole. And spike proteins latch into the centriole and then they exert control over the cellular replication process to do something called Filopodia. And Filopodia, okay, so we think of like, okay, two cells, one is infected, one's not. And we're told this model of like, okay, well, you know, the infected cell, it's hijacked and it starts replicating spike proteins. You know, it hijacks the machinery and it starts self-producing itself to infect the next thing. And then we're typically told like, okay, it ejects the spike proteins into the fluid around it, and then they latch onto the next cell in the membrane, and then they go through the membrane. That's not how COVID works. COVID, the spike protein latches into the centriole, like I'm going to say agentically controls the microtubule lattice, influences it. And Filopodia is where a cell side, you know how neurons like spew out in multiple directions to, you know, have its side, have its shape and form. Filopodia is where, if you think of the movie Terminator, where there's that liquid metal guy where his arms turn into long
spiky
like
things,
swords or whatever. Filopodia looks exactly like that. It converts the cell into a needle on one side to inject into the membrane of an adjacent cell, and then it drops off spike proteins to infect the next centriole to control it.
How different is that? How different is that from other cells? Like, how different is it from other viruses?
It's very similar. I mean, it's very similar.
Okay.
Yeah, spike protein, like part of the spike protein, I believe, is the RNA that it carries to replicate itself. Evades detection easier.
Yep.
But still that same thing of the spike proteins just wanting to do this, knowing how to do this. It only makes sense in the context. This is not a molecular thing. This is, and if we know, I mean, you know, again, studying microtubules, you understand that they probably have consciousness. So there's consciousness at multiple scales.
Yeah.
Like humans are this culmination of like more microtubules. We're more conscious than just a single microtubule, but we're this building, like stacking, growing field of consciousness in the human body. So spike proteins seem to know how to hijack consciousness, and the forces that consciousness exerts with microtubules as well. So anyway, that's pretty mind-blowing.
Yeah.
And you were asking another question
about the psychology about it. I mean, I've got a bunch of other follow-up questions that go into like how the neuronal model of consciousness, while being very interesting, may be totally wrong, as many theories have been wrong throughout the history of science. So there's nothing to assume. I mean, there are basic science facts that are probably beyond question at this moment because we've done so many experimentations on physics and other things. But anytime you get into biology, it's such a complex system that it's like that it feels like biology is the least amenable to these theories of everything that will be irrefutable, in the same way that the physics, the four forces of physics types of things, like we're getting close to the all four types of physics being under one model of string theory becomes is being able to be tested. So with biology, it's just like totally complex. And this neuronal model that we've had for the last, you know, I forget I use a Spanish guy, who's the Spanish guy, the who created in Madrid.
Carhall.
Yeah, exactly. Yeah. And I think Damasio writes a great book about how it might be different, and he brings into glia, which I would love to talk about glia as well and how they fit into all this. But basically, the neuronal model might not actually be the model for how we get. It might just be doing something else with neurons, and neurons are really important, but they're not the thing. They're not the thing that, and all these people are trying to fit the neuronal model into the consciousness thing. And it brings into something else. I might have even got this from you or someone else on Twitter, that 95% of life is not learning through neuronal synapses. They're learning through DNA, in the sense that a flatworm is just running around there and then dies because of something, and then has their progeny that learns something, basically. And that's the way that learning works for the rest of life. And what you said about microtubules and all these things, the fact that, so actually this goes back to the original question we got off on a tangent for, is you had these progenitor tubules that exist. And so I asked, the microtubules, they're in human beings, maybe in other mammals. Where are the tubules, or these progenitor tubules? What percentage of life is running off of either microtubules or the progenitor?
So yeah, like if you look at the neuron model, most people kind of get lost like in a membrane potential and like electrical firing of neurons, and that's like the model of consciousness is like an electrical field.
Yeah, interesting.
Um, but if you really learn microtubules, again, I decided a long time ago that I'm never gonna like I mean, I think there's many ways that I'm contributing to the discourse on these things, which is cool. But I realized like once I learned Stuart Hameroff's model of like microtubules and consciousness, it's one of those, it's kind of a sticky idea, I'll admit. It's hard to go back to the old way.
Yeah.
And I think there's a resistance in like, don't teach it because it just distorts someone's perspective. And there's a fuzzy in between if you're like a hardcore neuro trained person, and then somebody's like, well, what about the microtubules? And like I'm not asking questions like, what about the Krebs cycle, and like all these like these highly complex things, like people get lost in those.
Yeah.
There's value to those, of course, but you start talking about, I'm like, microtubules though, microtubules. And so you start to see neurons is really the membrane of microtubules, and this you conceptualize it in this kind of more fluid way rather than this discretized like step-by-step consciousness kind of model. So consciousness is more of a fluid thing, which is I think our experience of the world does seem more fluid.
Yeah, it's not linear. It doesn't feel like reality is it feels like my understanding of reality is linear, and it feels like the language that we're using is linear, but it feels like the base reality is not linear. And I think that many people fool themselves into thinking that reality is linear because it's much more comfortable. It's not a comfortable experience to realize that a lot of the way that humans operate and communicate and all these things are not an actual, they're just an image. They're an illusion, that the reality is like deep territory, which you can't really just like gloss over and say, oh, no, that's not real. Yeah.
I think that's why people, when they hear Orcoar, they're like, oh yeah, that makes sense. If people, it's not it's a dangerous idea if you're trying to defend a model of the brain of how people work that's intended to sell you on, take this pill and modify your neurotransmitters, because there's a lot of money in that. So the financial incentives are there to continue to push this old model of just it's synapses and neurotransmitters and electrical potential. That's it.
Which doesn't have much left there. I mean, I'm not doing the peer review. I'm not going into all the how these things. Well, the peer review brings them to another. Like, that peer review is a product of industrialization of science, and science was pretty fine before that appeared. And it's not a core fundamental, like it didn't exist in the 1800s. Albert Einstein was directly publishing to journals. There was no peer review. It came abroad with industrialization of science. Industrialization of science gave us a lot of beautiful things, very interesting things. Like but it also doesn't mean that it's going to work forever. And this could be a good conversation too, to kind of wrap it up for the last 10 minutes, is that the industrialization of science, while being helpful for things like, for example, AI, LLMs, large language models, all those things are products of industrial of science. But there's this sort of like unfetteredness of science, which happened before industrialization of science, which gave us all of the stuff that we're now talking about. And that seems to have been lost because now it's all running on grant money and like how well you can make the case to the government or the labs and about why this is so important, which may actually block us off from whatever like new discoveries are out there. There's something to be said that it's just so complex now that our models are so complex that maybe that old science maybe just doesn't have a place anymore. What do you think? Do you think there's a place for it? How does science evolve now in the next 10 years?
Yeah, so once it's a real trip to look at a cell and in the back of your mind to be looking for consciousness,
Yeah.
like
Yeah.
in all these processes. But what it would also indicate, I think the big paradigm shift that I think we will start to open up more to is the idea of there could be a way through human consciousness, through agency, our own agency, where I might be able to think like, okay, I'm sick right now, or I have an illness, or I'm in pain, or I have something going not so well in my body. Maybe rather than the first thing I reach for is a chemical modification, is maybe, look, if I am conscious because of my microtubules,
Yeah.
and we also know that microtubules are influencing the processes of cells, then wouldn't technically consciousness be a way to access the functionality of your own body? That would be the portal to do it. So you could start saying, okay, well, could you develop a model of psychology, a mapping of the human consciousness that is like a machinery tool to resolve maybe genetic issues potentially, or maybe modify your body through the process of what we consider thought. Which, I mean, I think there's support. It's not certainly something it's getting some play in academia, but if you go outside of academia and you look at like the woo-woo camp, they're all talking about this kind of stuff, like, oh, you can like intent your body to heal and all this kind of stuff.
And
So I find that
in Lindy, like it's like I'm now like far beyond the point where I need to justify the things that work in my own life based on the scientific method. I love Huberman, I love what he does, but I also think that he's sort of a priestly class of scientism. Like that for my own life, you know, listeners can do whatever they want, but for my own life, like I don't need to justify why things work. The Awakening from the Meaning Crisis by John Vervaeke, I love. Have you heard of the John Vervaeke's Awakening from the Meaning Crisis?
I know his work, but I'm not familiar with that
So
precept.
it's a brilliant naturalistic attempt to take everything we've learned from thousands of years of brilliant philosophers before the scientific method and then after the scientific method to understand why these things work. All the stuff that the affirmations, all those things. Why does it work? What is consciousness's role? I believe he touches on a few of the OQR, the specific thing that you're talking about, the consciousness model. And so, but it's completely naturalistic, and I love it. But it sometimes feels like he's the meme, the GIF, where from not from Arrested Development, from Always Sunny in Philadelphia, where he's got the conspiracy theories behind him, and he's trying to like pin everything together.
Like,
yeah,
red line and everything. Yeah.
Because he's trying to fit it all. He's trying to fit it all into this. Like there are things that we don't understand in the current model. Like so. Hopefully I can get to the original point of why I brought that all up. Oh yes, so he talks about the imaginal, and it's either Carl Jung, Corbin, or other figures who talk about the imaginal and how the imaginal is different than imagination because imaginal is tapping into things like symbols, deep symbols of justice. And justice is the symbol justice points to something much deeper in that infinite thing and into our archetypes, into who we are. And so what I love about what you said is that that could be how it plugs in. The imaginal feels like that, like actually building a model inside of the archetype of the cell itself and like coordinating the cell using thoughts to heal something feels solid. Like it feels like, but it doesn't even need to work like in the scientific model, like, yeah, sure, if you want to explain it, then you need the scientific model, and that's good, and that's, I think it's important. But at the same time, it's like, just do what works as well. Like, yeah.
Yeah, I mean, I think I'm a big fan of just saying, well, clearly there's something
Yeah.
there.
Yeah.
I definitely see that. I've seen it in my own life. I've seen it in countless people's lives. That yeah, there's like the power of intention or incantations that you say to yourself. Like people's own internal dialogue will manifest itself in
Yeah.
their health. Like you can talk yourself into feeling sick. You can talk yourself out of feeling super sick, or you can use models of meditation or insight meditation to help resolve chronic pain.
Yeah.
Um,
This,
not
that
not always, but sometimes.
what you just said about chronic pain is really important, because it's something that I've suffered for a long time. I've gone to the medical science establishment over and over again, and each time I came out with a medical error that got me deeper into the thick of it. And like eventually I had to realize that none of it works. The SSRIs don't work.
Right.
Like exercise works. I really love the medical model of exercise. Exercise is great. Sunlight in my
Yeah.
eyes is great. But
Mm.
anytime I go for that pill, it doesn't solve the original thing inside of the chronic pain. So there's like, it's like at some point I just had to give it up. That's why like all these things that you're talking about are really important, I think. Like it's just like but the wonder pill also is an interesting thing, and maybe we can leave on the wonder pill, because it is a very attractive idea to have a pill that works, that does this thing. And all, I mean, Xenon, like I don't think you're saying go and do Xenon in order to figure it out. It's like it's a test basically, and this brings into psychedelics as well. The main thing that did help a lot with chronic pain was something called iboga, or
Mm.
ibogaine. Like though that was a very helpful, but it's not a wonder pill. Like you give a sacrifice, which is like you go through this terrifying experience in order to
Right.
find some, yeah. Which Xenon
Yeah,
also
yeah.
sounds like it might have that bit too,
It,
where it's like you're messing with, yeah.
it does do that. And that's yeah, that's I mean, I think we started talking about Xenon. We could kind of end it on
Yeah.
Xenon. The reason why there were two reasons why I ever considered something like I've done that.
Yeah.
And the reason why was one, I had ulcerative colitis, which gave the manifestation for me was extreme abdominal pain, like in my pelvic bowl, like as if I'd been shot, and then just like this. I'm like, I'm losing out on life. Like this sucks, and I'm in pain, and that as an anesthesia does help with pain. So there was that, but also um, there's Orco-R, which talks about xenon and anesthesia as it affects microtubules and consciousness. And then there's a third magic ingredient that was just a coincidence from the world. It was this female researcher from Norway messaged me about Orco-R, and she told I was asking people in general on Twitter, can you send me your HRV screenshot
Yeah.
through the night, heart rate variability, which is a measurement usually of like autonomic balance between fight or flight versus relaxation levels. And she was like, oh yeah, my HRV is like 220.
Uh,
And when I heard that, I was like, no way. You must be like an insane athlete or something like that. And she's like, no, I do heart gratitude meditation.
yeah.
And part of her work involved, this is actually like her master's thesis was heart gratitude meditation, but also with ketamine.
Oh, yes. Interesting.
Yeah. And so it puts you into it like a nice, I call it like onboarding an anesthetic. You onboard it into your body. And but then you put yourself into a state of gratitude. And the process, so I was like, well, I have to try this because as a vagus nerve guy, anytime I hear somebody say their HRV is 220, normal, like a healthy person, like really, really healthy, like is 90 or 120 milliseconds. It's rare. It's very rare to be like 180 or above. So it's like, okay, well, I got to try that. but I was also in pain. So it's just like perfect storm to try this stuff for me. And but in the Xenon experience, I call them, I actually like have long notes that I have published now. I call them the Xenon sessions because I had some pretty wild insights on that. And what was the most healing for me was seeing my life stretch out in an infinite line and seeing it all at once, but being in this state of gratitude. Something about the different moments from my life that kind of popped to the surface and revealed themselves were like connecting dots to show me like, okay, you're here right now because of these specific moments. And it was like, oh my God, it literally felt like I was like looking at my life from a creator perspective as a master God. Like I became the all-seeing eye of my own life, and I could see the key moments, like, you know, meeting Stuart Hameroff at UC Berkeley, right, in 2014 in person, working on ultrasound then, you know, having a slight suggestion that you might want to look at the vagus nerve with ultrasound, and then trying that and inducing an out-of-body experience with ultrasound on my vagus nerve when we had been doing research on the brain more, you know, we developed millions of dollars of equipment to get ultrasound through the brain, through the skull into the brain to elicit effects. And it turns out that just moving the ultrasound transducer a little bit further down to the neck region is where the psychedelic experience really came from. So on Xenon, I was able to see all of that all at once. It was like, it makes sense. And my pain went away, obviously, because of the Xenon, but it just stayed gone. So something, yeah, no, it's gone. Yeah. I was taking on average daily like 5 Tylenol, 3 Tramadol, you know, which is less addictive opioid. And also they prescribed me SSRIs for the pain and all this kind of stuff. Never worked. I mean, it made me drowsy, so I just laid in bed and slept.
It did some things, yeah.
It did something, but no, this healed me. But it wasn't just, you know, people think like,
it wasn't the substance.
Xenon healing you. No, it was a conscious thing that was happening, a reformulation of consciousness. And I really want to know what that exactly was so that other people can do it too. I think that's a very important mission. And so, yeah, I think you can't abstract out the conscious thing that happens when you do those types of compounds, and why they are able to heal people. And I mean, gratitude itself as a feeling or a state of mind. I mean, let's think about it. Gratitude is just a word. Gratitude is a word representing a place that you can kind of put yourself into. It feels like you put yourself into a place. Now, if you think about these bigger concepts of like Platonic world and the mind and locations in space, time, geometry, gratitude might be some kind of a hidden curvature in the space-time crystal or whatever. Like there's these deep world has a manifold shape to it. Gratitude, and it's not just like, I can't just like be grateful. Like that doesn't work.
Yeah.
The way that I've done it is, you know, is probably a combination of like Kundalini type of practices. Kundalini would be like, you know, doing these kinds of interesting with your hands over your, and it only works when you actually move your hands over your body. Right. And doing that and being in gratitude and then onboarding an aesthetic that gives you the access to the sensation of the infinite, which literally feels like, I mean, it felt like I could see 60 years into the past and in the future. Like before I was born even, like I literally felt like, I'm like, okay, I'm seeing something that like my grandma would have seen before I was born. Like, so, I'm like, that's probably my DNA. That's probably like my DNA is encoded with consciousness too. And DNA has exact mechanisms that would allow it to have consciousness as well. So DNA has a consciousness to it additionally. Same exact 3.7 angstrom features between the components in DNA. So it would be a mechanism where microtubules could communicate with DNA, which seems like what it is happening anyway. But yeah, I think I'm not recommending that people go out and buy Xenon. It's extremely expensive. I will say though, I am working with a couple of engineers to figure out ways to make it more affordable for people,
synthetically,
or recyclable, which is really cool. Is you could technically, with, I think a person would buy one lifetime supply of Xenon and then endlessly recycle it because it doesn't break down. You can recycle it again and again and again.
So, but through the bodies, through like
externally.
Yeah,
externally. So what you do is you inhale it. You have the effect. You do a you do like a 1 hour session, essentially, like,
it's not intravenous. It's not intravenous.
It's gas. Yeah, you take it as a gas.
Yeah, got it.
Usually like a balloon, or you can do it through a mask or whatever. Or like I have some people who are now doing it through the nose, like like in like Paul Atreides from Dune kind of stuff. And I wouldn't say I'm helping people do it, but I'm just like, here's how you would do it.
Yeah.
And so I'm publishing that kind of data. Because I'm like, honestly, I'm a business guy too. And I also recognize, like, in life, it's the best idea that I ever heard in a business context. Because I run a like online educational stuff on these things, of course, like ultraschool.com is that. But I'm like, I don't necessarily want to charge for this information, because literally it could be the best contribution to humanity that I ever make, is informing people that there's something really powerful there. And it's, yes, Xenon is a drug, but it's not a synthesized drug. Xenon got onto the planet because there was a big asteroid full of Xenon that crashed into the planet. Earth was grown in a Xenon-rich environment.
Wow.
Actually. So Xenon actually dates back to our early origins. And also, since life probably is more microtubule centric, growing in a Xenon-rich planet, Xenon has probably been part of the core, like, development of consciousness. We talk about the stoned ape theory a lot. Like, yeah, chimpanzee ate a magic mushroom and developed consciousness. Like, no, the consciousness development through psychedelics, or through chemistry, or through quantum chemistry, more or less, is our earliest origin theory that we have right now. So, but yeah, I think I want to formalize this more, because I think there's something huge in there. It gave me my life back, and that's worth talking about, because I know how I was very close to just ending it. Honestly, I was like, I can't do another 2 years of this pain. I can't. And I was just like, why not? I'll try this. And I did. And apparently Xenon clinics are all, like, they have Xenon clinics in Europe now.
Interesting.
Like, so, like, just like they would have ketamine clinics in the US. But I'm like, honestly, Xenon doesn't have any of the side effects that long-term ketamine use does. So I think it's definitely more preferable. In overall, it doesn't really have any negative effects on your physiology. It's in there, and then it detaches, and then it floats away. Yeah.
Brilliant. Well, thank you so much for coming on the show. How can people find out more about what you're working on?
Yeah. So if you're interested in kind of the stuff we've talked about today, and you want to try some of that stuff and try ultrasound as well, as I had indicated on the neck, I have a live, I have a live recorded webinar replaying on ultraschool.com, just a single landing page with that video. And you can kind of see the method of how to start tapping into the microtubule network a little bit more for yourself. And if you want to join, we have a paid group, very low, $7 a month. I would love to give it away for free, but at least I still have to pay, like, hosting for video costs and stuff like that. So it's really just marginal. But I'm really fascinated by these things and I want to share. So yeah, ultraschool.com with a school with a K. So
Cool. Yeah. Thank you so much.
Thank you, man. Thanks.